A 10-year-old boy is asked to add the numbers 1 through 100. While classmates grind through calculations, he writes a single number, 50-50. How? He paired them. 1 plus 100 equals 101. 2 plus 99 equals 101. 50 pairs, each summing to 101. The answer, 50 times 101, equals 50-50. That boy was Carl Friedrich Gauss. And that trick was the least of what he would do. Last time, we met Jean-Victor Poncelet, who invented projective geometry in a Russian prison cell, working without books, reconstructing mathematics from pure memory. Welcome back to Men of Mathematics. Today, we meet the greatest mathematician since antiquity, Carl Friedrich Gauss, the Prince of Mathematicians. Number theory, statistics, geometry, astronomy, physics. He transformed everything he touched. Carl Friedrich Gauss was born on April 30th, 1777, in Brunswick, Germany, to a poor family. His father was a gardener and bricklayer who discouraged intellectual pursuits. But Gauss's genius was so extraordinary that it attracted the attention of the Duke of Brunswick. The Duke funded Gauss's education, and the young prodigy never disappointed. At 3, he corrected his father's payroll calculations. At 10, he invented the pairing trick for arithmetic series. On March 30th, 1796, Gauss was just 19. He made a discovery that determined his career. He proved that the regular 17-sided polygon, the heptadecagon, can be constructed with compass and straight edge alone. This was the first new constructible polygon discovered since the ancient Greeks, over 2,000 years earlier. It showed that pure algebra could answer ancient geometric questions. Gauss was so proud that he asked for a 17gon to be carved on his tombstone. At age 24, Gauss published his masterwork, the Disquisitiones arithmeticae, transforming number theory from scattered results into a systematic science. The book introduced modular arithmetic notation and proved the law of quadratic reciprocity. The notation A is congruent to B modulo n, means A and B leave the same remainder when divided by n. This simple notation, invented by Gauss, revolutionized how mathematicians think about numbers. Gauss called quadratic reciprocity his golden theorem and gave multiple proofs throughout his life. It answers, when is a prime P a perfect square modulo another prime Q? The reciprocity is remarkable. Whether P is a square mod Q depends on whether Q is a square mod P. On January 1st, 1801, astronomers discovered Ceres, the first asteroid. After just 41 days of observation, it disappeared behind the sun. Where would it reappear? Using his newly developed method of least squares, the 24-year-old Gauss predicted Ceres's position from the sparse data. When astronomers looked on December 31st, 1801, there it was, exactly where Gauss had predicted. The bell curve that appears throughout statistics is called the Gaussian distribution. Gauss developed it while analyzing measurement errors in astronomy. The central limit theorem explains why this distribution appears everywhere. The sum of many independent random variables tends toward this distribution. In differential geometry, Gauss proved his remarkable theorem, the theorema egregium. The curvature of a surface is intrinsic. It depends only on measurements made on the surface itself, not on how the surface sits in space. This explains why you can roll up a piece of paper, which has zero curvature, but can't flatten a sphere, which has positive curvature, without distorting it. Gauss discovered non-Euclidean geometry decades before Lobachevsky and Bolyai published. But he never published, fearing the clamor of the Boeotians, the controversy it would cause. When Bolyai's father sent him his son's independent discovery, Gauss replied, "To praise it would be to praise myself." He had found the same things decades earlier. Gauss's motto was pauca sed matura, few but ripe. He published reluctantly, wanting every work to be polished to perfection. Many discoveries were found only in his notebooks after his death. Bell criticizes this secrecy. Had Gauss published all his discoveries, mathematics would have advanced decades faster. Beyond pure mathematics, Gauss made fundamental contributions to astronomy with celestial mechanics and orbit calculation, to physics with magnetism, optics, and electrostatics, to geodesy with surveying and mapping the Earth, and to statistics with the method of least squares and error analysis. The unit of magnetic flux density is called the Gauss in his honor. Gauss's doctoral thesis proved the fundamental theorem of algebra, that every polynomial equation has at least one complex root. He gave 4 different proofs throughout his life. Gauss spent his later career as director of the Göttingen Observatory. He was not an easy collaborator, secretive, critical, and suspicious of others' work. But his mathematical output remained extraordinary until his death in 1855. Carl Friedrich Gauss stands with Archimedes and Newton as one of the 3 greatest mathematicians of all time. Number theory, statistics, differential geometry, astronomy, he transformed virtually every field he touched. His motto, few but ripe, produced works of lasting perfection. What he didn't publish, non-Euclidean geometry, elliptic functions, complex analysis, others would discover decades later. There's something bittersweet about Gauss's story. The poor boy from Brunswick who became the prince of mathematicians, the genius who hoarded his discoveries, the perfectionist whose unpublished notebooks contained more mathematics than most careers produce. If others would but reflect on mathematical truths as deeply and as continuously as I have, he said, they would make my discoveries. As E.T. Bell wrote, the Princeps Mathematicorum, the Prince of Mathematicians, is the title by which Gauss is known. He changed the whole course of mathematical thought. Next time on Men of Mathematics, we meet Augustin Louis Cauchy, the great rigorist who made calculus precise. He replaced vague infinitesimals with epsilon-delta definitions. He created complex analysis. He also lost Abel's paper and dismissed Galois. The architect of rigor was not always kind to genius. Thank you for joining us on this journey through mathematical history. If you're inspired by the Prince of Mathematicians, subscribe and hit the notification bell. New episodes release every week. I'll see you next time.